All right, welcome. This is grade 5, module 6, the homework, lesson 1. Now remember, you should have done the problem set in school. You should have done the homework already. This is just a help for you, because if you're just going to look at my answers, that's not really going to teach you anything. But this is here just to help you out. All right, so let's look at the first lesson. This is all about coordinate graphing, so we're going to build to that by learning first about the lines. It says answer the following questions using number line Q. There is number line Q. What is the coordinate of the distance from the origin of the smiley face? So here's the smiley emoji face, and the origin is what? Yeah, the origin is the beginning, or 0, basically where we start. So we count 1, 2, 3. Okay. What is the coordinate of the lightning bolt? So here's the lightning bolt. We look at how much each space equals, and we can see that each tick or each space equals 1. So 3, 4, 5, 6, 7, 8. Okay. What is the coordinate of the heart? Now instead of counting each one, we're going to go to the heart. We know each mark, each tick, that's a tick, is worth 1. So we're just going to start at 12, 13, 14. We could have counted backwards, been at 15, and go back 1 if we wanted. So 14. What is the coordinate of the midpoint? There's a new word for us, midpoint of the lightning bolt and the heart. So here's the heart at 14, and here's the lightning bolt at 8. So how do we figure out what the middle is, or the midpoint? Well, we can count. 1, go back 1, go forward 1, go back 1, go forward 1, go back 1. This is the midpoint, right? So it shows us the middle between 8 and 14. That is 11. Great. Let's look at number 2. Use the number lines to answer the questions. Plot T so that its distance from the origin is 10. So we know that this is 1, 2, each one is worth 1, right? So 3, we can count by 3, 6, 9, and this we're going to put, well, I'm going to put it below it. Point T, right? We know that that is 10. All right, plot M so that its distance is 11/4 from the origin. Now this one is a little different, right? Because if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that's not right because this says it's 3. Got something under there. This says it's 3. So notice that this is a fraction, right? It's a fraction greater than 1. We have to think to ourselves, what is 11/4? Well, it means that we're going to convert this and say it's one group of 4, that would be 1, another group of 4, that would be 2. We don't have a third group, right? We only have 2 groups. So when we look at this, it ends up being 2, right? And 2 times 8, and 3/4. So the distance, 11/4 from the origin. What is the distance from P to M? Well, we first have to put M on here. So we know it's 2 3/4, right? So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8, 9/4, 10/4. Here is M. So that is the first thing we have to do. See how we figured out that that was 2 3/4? Now we have to figure out what is the distance from P to M. And we know this is 1, this is 2, so each one is a 4th. So we can count 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. So the answer is 6/4, or we can convert that and say the answer is 1 and 2/4. Either of those are correct. That's the distance from P to M. All right. Plot a point that is 1/1500ths closer to the origin than Z. So, again, we have to look at what the scale is. How can we figure out this one is actually going backwards? This is 1, and this is 7500ths. So let's count. 1. Could this be 9/10, 8/10, 7/10? Nope, because 7500ths is here. Must be counting by 90. We're counting by 500ths. So 9500ths, 9000ths, 8500ths, 8000ths. See, so I looked at that and I said 1, 2, 3, 4 spaces. Right? So now the question is, plot a point that is 1/1500ths closer to the origin than Z. Well, here's Z, and the origin is over here. So we need to get closer to it. So 500ths, 1000ths, 1500ths. And we're going to put the point right here, because that is 1/1500ths closer to that point. Okay, we just are counting backwards basically. And this last one on the side here, plot U so that its distance from the origin is 3/6 less than that of W. So when we look at this, we know that we're counting it in 6 because this is 9 and 2/6. So this is going to be 9 and 1/6, 9 and 3/6 because 2/6 is there, 9 and 4/6, right? And what it wants us to do is plot a point that is 3/6 less than W. So here's W. We want to make it smaller, right? So we're going to go 4/6, that's 1/6, to 3/6, that's 2/6, and now we've gone 3/6 away from W, so this would be point U. Okay. Let's look at the back. Number 3. Number line K, there's the K, shows 12 units. Use number line K below to answer the questions. Plot a point at 1. Label it A. Okay, so this is 0 and that's 2. 1, 2, nope, it can't be counted by ones. Well, let's count the parts. 1, 2, 3, 4. Right? Since there are 4 parts here, I know that each one has to be a half. So a half, 1. Here is point A. I'm going to check that off. I did that. Label a point that lies at 3.5 as B. Right? So we know that this is 2. We know that this is 4. We know that this is 3, right? 2, 2.5, 3, 3.5. Right? So we're going to call that B. Label a point C whose distance from 0 is 8 units farther than that of B. The coordinate of C is what? So we need to go 8 units away from B, right? So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. Now, the reason it doesn't go there is because, remember up here it says it shows 12 units. So that means this is 0, 2, 4, 6, 8, 10, 12. So in between, I'm just going to label each unit here. Oops. What I do? 5, 6, think I made a mistake, and that's okay. I'm just going to fix that. 7, 8, 9, 10, 11. So I have to go 8 units away. So I'm at 3.5. I need to go to 4.5. So here's 3.5. Here's 4.5. Here's 5.5. That's 2, 3, 4, 5, 6, 7, and here is 8. So every 2 lines equals a unit. So I am at 11.5 for that. For point D, I have to find a distance that is 6 halves, right? 6 halves less than B. So I know that these are halves, right? So I have to go 6 halves. 1, 2, 3, 4, 5, and 6. Right? Each one of these points from here to here is a half. Right? So we have to remember that when we're counting. So what is that point? 1/2. Here, what is the coordinate of the point that lies 17 halves farther from the origin of D? So here is the origin. This is where we start for D. And we have to find a point that is 17.5 away, 17 halves. So we can just count 17 halves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And we're supposed to label that point E. I actually wrote a 9 underneath it, so I already have my answer there. E, we know, is 9. Right? Label the coordinate of the point that lies halfway between F and D. So D is here and F was already given to us. So we can count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm still not in between. Get 1, get 1, get 1. There it is. It's 5. Now, I did it that way. Another way you can do it is just count all the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 18 spaces. So 18 divided by 2 is 9. So I need to count 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the middle, and they told us to put that as G. So G is at 5. And the last one, Mrs. Baker's 5th grade class buried a time capsule in the field behind the school. They drew a map and marked the location of the capsule with an X so that the class could dig it up in 10 years. What could Mr. Baker's class have done to make the capsule easier to find? Well, they could have taken steps, right, to find out where it was. Say, oh, this was 15 steps and this was 10. They could have actually measured the distance, right? They could have measured the distance of the playground and the field and then figured out how far it was, right? They could have, because you're basically using the information from the number line to figure out how far it is away from the baseball field and away from the playground. Just like we did up here, using different indicators to figure out how far it is. All right, I hope this helped you. See you next time.